Hello everyone, welcome to ACE Engineering Academy. Today we are here to discuss GATE 2026 Computer Science Examination Solutions. We are here subject experts. Let me introduce subject experts. Ramesh sir, who is going to teach computer organization, and then Manikanta sir will teach mathematics, and aptitude teacher, that is Rajesh. Next Venkateshwar sir, he is going to teach computer networks and operating system, and Vamshi sir, he will teach discrete mathematics, and then TOC Dasharatha sir, he is going to teach TOC and compiler design, and DBMS Ramesh sir, he will teach DBMS, and myself Dr. Srinivas, I will teach algorithm and then data structures and programming course. Okay, and we collected questions based on the memory. Okay, after having discussion with the students, we have collected. We will try to provide best and quality solutions, friends. Okay, so thank you. Thank you.
Right. Okay, na? Right. Japan. Yeah. Hello, students. Here with us, Dr. Srinivas sir is there, and yeah, myself Ramesh Masuna and all our faculty members have collected some questions from our students. And based on the feedback of the students, we would like to discuss about how was the paper of GATE 2026 morning session paper. Sir, I have heard that paper is the moderate to tough, the most of the students are telling. And when comes to your subject, like programming, data structures and algorithms, what you feel about it, sir?
Yeah, and thanks for giving the opportunity for teaching algorithm, data structures and programming. So what I noticed and personally experienced, most of the questions from algorithm, data structures and programming questions, most of them are interrelated to our class notes only. Students who practice all those questions, definitely they will get good marks. Not only that, I heard from some of my faculty like COA, computer organization sir, and then computer networks sir, DBMS and you, and operating system and theory of computation, discrete mathematics, all other faculty, what they are collectively telling that. So most of the questions are related to our class notes only. Okay, I hope most of you did very well. Okay, let us go through subject wise. Okay.
Sure. And even I have seen most of the DBMS and compilers questions are directly from the notes, and some of the questions are what I have said is expected, and even that expected questions also appeared in this GATE 2026. And according to my knowledge, so what I feel is the students who prepare all class notes questions, practice questions and PYQs, they can easily able to solve, sir.
Correct.
What do you feel, sir?
Yes, it is 100% correct, because I went to the examination center, I collected some questions from the students as well as, so they are really very easy questions. Okay, and overall paper quality is moderate to hard. Okay, so
sir, just elaborate the subject wise the weightage, and then we'll start subject by subject the discussion of the questions that we have collected, sir. Right, sir.
So now I welcome Mr. Ramesh Masuna sir for teaching database and management system. We'll go through order. Yeah. So according to order, that is a discrete mathematics. Yeah, let me take a weightage of this one. So discrete mathematics, actually it is memory based, so therefore maybe 1 or 2 questions may be differ, okay. So 1 mark question is 1 and 2 mark questions are 2. Whereas in engineering mathematics, there are 4 1 mark questions and 1 2 mark questions. And algorithm subject, that is 2 1 mark questions and 3 2 mark questions. And compiler design, they ask 1 question from 1 marks and 2 questions from 2 marks, okay. And then computer networks, there are 2 questions of 1 marks and 2 questions of 2 marks. And computer organization, there are 3 questions of 1 mark and 4 questions of 2 marks. And programming and data structures, there are 3 questions of 1 mark and 2 questions of 2 marks, friends, okay. And then digital logic, there is 1 question from 1 mark and 2 questions from 2 marks. Operating system, there are 2 questions of 1 mark and 3 questions of 2 marks. And then theory of computation, there is 1 question from 1 mark and 2 questions from 2 marks. Obviously, these are memory based analysis, okay, maybe 1 or 2 questions may be differ here, okay. So I think now I am welcome Mr. Ramesh sir. He is going to explain in detail solutions of database management system. Thank you, sir.
Thank you, sir. Started. Right. Start online. Yeah. Hello students. Now I am going to talk about the DBMS questions that I have collected from the students, and what are the detailed solutions of each of the questions. Here is a question: consider relational database schema with relation R of A, B, C, D. Means a relation is given with 4 attributes A, B, C, D, and if A, B and AC are the only 2 candidate keys, means the relation do have 2 candidate keys, and one candidate key is called AB and another candidate key is called AC out of 4 attributes A, B, C, D. Now question is the number of super keys. As I was telling in the classroom, like previously questions asked on number of super keys on when one candidate key is there. I told you this time it is possible to ask questions on 2 candidate keys, number of super keys. So as I said, it is came, right? So when 2 attributes are there with one candidate key AB, and super keys we have to find according to the other attributes. AB along with other attributes are CD. So with 2 attributes we can have 2 power 2 combinations, plus with AC along with other attributes, those are called B and D. With these 2 attributes we can frame 2 power 2 combinations, and we have to eliminate the combinations that are possible with other than the key attributes. Other than key attributes are AB, AC are the key attributes, other than key attributes are D. So minus 2 power 1, that is 2 power 2 4 plus 4 minus 2 power 1 2, that is 4 plus 4 8 minus 2, that is 6. So the number of super keys are 6. So answer for the question is 6. So it's simple, and we have solved the question in this way. If AB along with other attributes we have a CD, and AC along with other attributes we have a BD, with CD 2 power 2 combinations, with BD 2 power 2 combinations, common attribute D minus 2 power 1, which is equals to 6 super keys. This is a simple straightforward question that we have solved in the classroom. And the second question what I have collected is consider relation R of A, B, C, D and functional dependencies of the form X to Y. Which of the following statements are correct? It is asked about which of the following statements are correct. I think it is MSQ type of question. Given PQ to R, then P to R, Q to R. So what does it mean? It is performing a decomposition on the left side, but decomposition not on the left side, decomposition should be done on the right side, because this option A showing the decomposition on the left side, it is incorrect. Second option, look at, if P to R, Q to S, then PQ to RS. What does it mean? With these 2 dependencies, you can able to get this dependency. So how to verify whether particular dependency is possible or not? By finding the closure of it. When you find the closure of PQ, using the 2 dependencies that is given, PQ closure is PQ, with P we are getting R, with Q we are getting S. Means with PQ we are going to get both R and S. So means P to R, Q to S is there, then PQ to RS is perfectly correct. Then if P to R, then PQ to R. How do you solve this? Only one dependency is given, and it is called augmentation property. If P to R is there, we add Q to both the sides, it becomes PQ to QR, and if you perform a decomposition, PQ to R, PQ to Q, you can write it. Or else, simple way to test, you can find the PQ closure with the given dependencies. What is the PQ closure in the given dependencies? PQ, with P we are getting R, with PQ also we are going to get R. This is also correct statement. And option D, you look at PQ to R, P to R, what it is asking? Q to R. So the same formula we follow, right? Means the same logic. To verify Q to R possible or not, you just take the closure of Q using these two. What is a Q closure? Q only, not R. So this is not possible. So here the answer is both B and C. And there is one theoretical questions. These points we have discussed many number of times. The question is, in the context of relational database normalization, which statement is true? Which statement is true? True statement. It is always possible to obtain a dependency preserving 3NF decomposition of a relation. So when you have to decompose a relation into 3NF, lossless property is possible, dependency preservation possible. Means up to 3NF, both lossless and dependency preservation is possible. That's why 3NF decomposition treated as most practical, right? So the statement is true. Look for option B. It is not always possible to obtain dependency preserving 2NF decomposition. So it is said not possible. Not possible is wrong. Means up to 3NF, lossless and dependency preservation is possible. So it is said not possible. So B is wrong. Then go ahead with the C option. It is always possible to obtain dependency preserving 1NF decomposition of a relation. Yeah, this is also, it is correct. So it is, it might be MSQ question. It might be MSQ question. It is not always possible to obtain dependency preserving BCNF decomposition of a relation. But up to BCNF, dependency preservation may not be possible. Up to 3NF, dependency preservation is possible. When you go to BCNF, some of the dependencies may be lost. We have discussed some example in the classroom, like if R is ABC, we have a dependencies of the form AB deriving C and one more is C deriving A. Now the keys are both AB, now A replaced with C, it is CB, two keys. When two keys are there, we can say C is not super key, but A is prime attribute. We can say this relation is in 3NF. But when you have to go for BCNF decomposition, we generally do lossless decomposition because data have highest priority. According to lossless property of decomposition, what we can do, C2A is violating the dependency preservation, sorry, C2A is violating BCNF rule, so C2A we take into separate table and remaining attribute B along with key we take into one table. So in this decomposition, C2A you can see in one table, but AB to C you can't see in the decomposed relations, maybe directly or indirectly also not possible. That's why dependency preserving decomposition into BCNF may not be possible always. So this is also correct statement. Because question is about true, so A correct, C correct and D is also correct. So only B is wrong because dependency preservation into 2NF not possible, it's said, up to 3NF it is possible. Okay, so option B is wrong. And here I will also cover some questions from the subject of compiler design, CD. Fine. From DBMS I have seen collected so far 3 questions. From CD I have collected some more questions. Just let us discuss in more detail about these questions. Which of the following statements is true? The LL of one parser are more powerful than SLR parser. Just understand the relationship of LL of grammars and LR grammars. The LL of grammars and LR grammars, we have discussed LR of 0 is subset of SLR of 1, is subset of LA LR of 1, is subset of LR of 1. And I have shown you some relationship between this LR grammar and LL of grammars. So we have shown a grammar like this. This is LL of 1, which is covering some part of LR of 0, SLR of 1, LALR of 1 and LR of 1. So here what it said, LR of 1, sorry, LL of 1 parser is more powerful than SLR. So I can just take some grammar here, okay. This grammar taken under in the blue circle, that is, we can call this grammar is LL of 1, but this grammar is not covering inside the circle of SLR of 1, means this is a grammar which is LL of 1 but not SLR of 1. It is a meaning that the grammar that is accepted by LL of 1 may not be accepted by SLR of 1. So it means LL of 1 accepts more class of grammar, simple. So that LL of 1 parser are more powerful than SLR parsers is a true statement, because question is about true. A is a true statement. B, LL of 1 parser uses backtracking. So LL of 1 parser is a tabular representation of recursive descent parser. Recursive descent parser does not uses any backtracking. So that saying uses backtracking is wrong. B is wrong. And option C, for a grammar to be LL of 1, it must be left recursive. We know that no left recursive grammar is LL of 1. If the grammar is left recursive, it is not suitable for LL of 1 parser, so it is wrong. For a grammar to be LL of 1, it must be left factored. It must be left factored. See, if A tends to small a capital B, small a capital C, if this is a grammar. Now this grammar has common prefixes A. If common prefixes are there, so in the A row, in the A column, we have to write A tends to AB and A tends to AC. It is causing more than 2 productions to appear in the same entry, causes the grammar to be not LL of 1. So to avoid this problem, what we have to do, we have to factor the grammar. So if it is not factored, it is definitely not LL of 1. If it is factored, it is possible to be LL of 1. Means for a grammar to be LL of 1, it must be left factored. This is also correct statement. Here I am reading all the options because we don't have a data of whether the question is MCQ or MSQ. That's why I am just explaining all the options. According to the data collected, we can say this question might be MSQ. So A is correct and D is also correct. And this is a question on common sub-expression elimination. Look at, consider the control flow graph. Some graph is given. And question is, which of the following options correctly list the set of redundant expressions? What is redundant expressions? Redundant expression is called common sub-expression. What is common sub-expression? An expression is said to be common sub-expression if it was previously evaluated and the variables in that expressions have not changed their values from the previous evaluation. Means, suppose A plus B I am calling common sub-expression. So it means it could have been already evaluated previously. Suppose an expression A plus B is already evaluated. From this point to the point of A plus B, neither A should not be changed nor B should not be changed. If A not changed, B not changed, whatever A plus B calculated at this point in the program, same A plus B calculated at this point also. Suppose this is assigned to X. So instead of evaluating A plus B one more time, this A plus B can be replaced with X. So recomputation can be avoided. That is the meaning of common sub-expression. Means only the point. If I am saying some expression is common sub-expression, it means that it could have already executed and the variables involved in that expression have not changed. Means no change of A value from this point to this point and no change of B value. So that is a point to be noted. Now see what is given. Common sub-expressions in the basic blocks B4 and B5. Only B4 and B5 it is asked. Just go back to the control flow graph. So in the B4 and B5, what are the common sub-expressions? In B4 we have a G star K. So if G star K to be common sub-expression, it could have already executed. So okay, G star K, it is already executed. G star K, it is already executed. And from this point to this point, we have one path, B2 to B4, B3 to B4. So if it is to be common sub-expression, G should not be changed. Here G, there is no change of G value, there is no change of G value, there is no change of K value, there is no change of K value. So I can call This G star K is a common sub expression. Now look for B plus I. If B plus I to be common sub expression, neither means B plus I could have already computed. Okay, here B plus I is already computed. From this point to B4, we have a two paths, B1 to B2 to B4, B1 to B3 to B4. Okay, two paths are there. In that path, the value of B here in this path from B1 to B2 to B4, B value not changed. In from the path from B1 to B3 to B4, the value of B changed. Because the value of B changed, whatever is resulted B plus I in B1, whatever is resulted in B plus I in B4 might be different, so it is not common sub expression. And look for in B5 we have a C plus M. So C plus M to be common sub expression, it would have already computed. Yes, here it is already computed, C plus M. It is C star 4. Okay, C plus M already computed. From this point B3 to B5, we have one path. In this path, just check any value of C changed. No value of C changed. Any value of M changed? No. So there is no change of C, no change of M. Then I can call C plus M is a common sub expression in B5. In B4, what is common sub expression? G star K. In B5, what is a common sub expression? C plus M. These are the common sub expressions. Now look at in B4, G star K, not B plus I. So A wrong, C wrong. In B5, C plus M is a common sub expression. So correct answer is option D. That is in B4 we have G star K. In B5 we have C plus M. So these are the common sub expressions in the respective blocks. Okay. These are the questions that we have collected from the students from the memory based questions, and I have covered the subjects of DBMS and compilers. If any further questions comes, again I will come back and we will discuss those questions. Stay tuned and don't go anywhere and check all your questions. Next, my friend Mr. Dasrat sir is going to cover the subject of TOC questions. So stay tuned, don't go anywhere. Thank you.
Hello friends, good evening. Welcome to the solution process of the GATE 2026 memory based questions. Here I would like to discuss about the memory based questions on the course of theory of computation. Here I got 3 questions from the various sources. Some of your friends also share the same questions. Most of the questions whatever I seen here, they are the theory based, and some of the questions are conceptually important, and some of the questions are here simply about the principle based. So there are 3 types of questions I have received here. One question is on the non-deterministic finite automata concept, and one question also on the regular languages. I also seen the question on the context-free grammars. So these are the 3 questions I received from the student friends. Now I am going to provide you the solutions on these 3 questions in detail. Let's look into this question here. This is the question on the non-deterministic finite automata. This is the completely principle based question. The statement whatever you provided appears like a multiple selection answer question. It is MSQ. As for the statement, let M be a non-deterministic finite automaton with the 6 states over the alphabet. Which of the following options cannot be the number of states in the minimal deterministic finite automaton that is equivalent to the M? So the question you can easily understand that NFA has been converted into the DFA here. There is a NFA machine with the N number of states. When you translate your NFA into the equivalent to DFA, the maximum number of states you can have here 2 power q. If there are q states in NFA, the corresponding DFA can have here 2 power q. That's the maximum number. And it doesn't mean that always we'll get here 2 power q. You may get here always the values must be less than 2 power q. It cannot be the more than 2 power q. So that is the basic objective of this question here. If you look into the options, with us we have the 6 states here in a NFA machine. There are 6 states in the NFA machine as per the statements. This one you wanted to translate into the DFA. So when you convert it into the DFA, again generally we go for the application of the minimization of the process. Even though we apply the minimization for the certain problems, we cannot reduce any number of states. Whatever you translated NFA to the DFA, that itself remains as a deterministic minimum state to DFA. So that's why you cannot always reduce the DFA states. There are certain problems you are also seen in the classroom where you cannot translate further a DFA into the reduced DFA. So that's why you can easily understand from here, if there are n states in the NFA, corresponding DFA can have at most 2 power n states here. This is what we are all aware about it. This is the basic formula. So when you are translating a NFA with the DFA, with the definitely you should have a 2 power n. With us we have the 6 states. NFA has got a 6 states here. Then corresponding DFA can have at most 2 power 6. This at most 2 power 6. This 2 power 6 is nothing but a what here? 64 it is. No DFA can have here more than this. So values must be less than or equivalent to 64, not more than 64. That should be the answer to this. If you look into the option A, yeah, 32 may be possible, or even one state in a automata also exists. But here in a C you got it as a 65, but 64 is the maximum. 65 you can't have it, and then this is also easily you can discard because if you wanted to have a 128, you should have about the 7 states in a NFA machine. So that's why as it is a multiple selection answer question, you have the 2 answers here. One is 32, other one is 1. These are the possible number of possible states, but what he is asking us, what cannot be the number? He is not asking about the possibilities, he is asking for the what cannot be. So that says what here, this cannot be the answer, this cannot be the answer, or this numbers cannot met by your DFA machine. Even if you take into that one, these two numbers are the valid right answer according to the question. So if you work on these answers, so 65 cannot be the number, 128 cannot be the number, but A and B can be the numbers as per the statement. Now let's move on to the next question here. This is about regular language closure properties. These properties are not on the just like regular language, it's a combination of the context free as well as the regular languages. So now we are looking for here these statements. We have two languages, L1 and L2. There are two languages with us, but two statements whatever you given in the next line, you see L1 intersection L2 and L2 both are regular languages. So there are two statements. One statement is L1 intersection L2, other one is L2. He mentioned L2 is a regular language here. Which of the following statements are always true? Here L1 intersection L2 also regular and L2 itself is also regular. If these two are always true, then what would be the correct answer according to these options? Here we are not aware about what is the L1. You have to trace out what is the property of the L1 here, whether the context free, whether it's a regular, whether it is a recursive. You have to figure it out what is the L1 here. That all you can easily find it out based upon the options and substituting these options into this statement, then you know about the properties. Now let us talk about L2 complement is context free. I am not sure about these options because some options whatever we have received from the students, they are not actually exactly matching with the property what I am trying to say here, but based upon availability of the options and all, I just trying to trace out what is the wrong, what is the right with the each option here. Now I am coming to the Q. L2 is a context free. Actually the statement what he provided us, L2 is a regular. Definitely what happened? L2 bar also regular. Every regular is also by default context free. If you look into this way, L2 is a regular, L2 bar also by default regular because regular languages are closed under complementation. Every regular language is a context free. If you take that aspect, definitely the statement what he provided, that is also true. As L2 is a regular, complementation is also regular, every regular is a context free, hence the statement A you can take it as a true statement here. And you are coming to this L1 union L2 is regular. You remember we have with us only L2 information. So L2 is regular, but here L1 is a another language. When it is a another language, this L2 may be regular, may not be regular. As for the statement, L1 is a regular, not regular here. There is another language here. If both are regular, you would say that its union is a by default regular. But the problem is here you know about only L2, but you are not aware about the L1. So as L1 may be regular, may not be regular, ultimately its union also may be regular, may not be regular. So that's what this may be true, may not be true. So that's what, but the statement he mentioned that is a regular. So that's why we will take it as a false statement. Now coming to the L1 is a context free. L1 is a context free. How come? So this is also seems to be the option is not appropriate here connected to this with respect to this question here. Slightly there may be the variation. It may be the L2 bar, probably L2 bar is the context free, like that you might given here. But actually this option is not appropriate with respect to that, I am sure for that, because we have the L1, right, and you are intersected with the L2, but when you intersected with L1 with regular, one is a context free, other one is a regular. When you intersected with the context free and regular, a result will be by default context free. Result will be by default context free. So what he mentioned according to this one, L1 intersection L2 is regular, he mentioned L1 intersection L2 is regular, but he mentioned L1 is a context free. So that's why this statement is also not correct to this. This is also false. And he mentioned that L1 is a regular language. Yeah, definitely this could be the right answer, because regarding the L2 already you have a as a regular, and L1 is a by default. You mentioned that L1 is a regular, because if L1 and L2 both are regulars, its intersection is also by default regular. So this statement says what? L1 intersection L2 is regular. If L1 is my regular, definitely its intersection is going to be by default regular. So that's why you can take this statement is also true statement here. So this is according to the availability of the data and based upon the options what we are remembered, that we are finalized here. And finally there is a one question I remembered from the grammar. In the grammar he mentioned here there is a context free grammar with us. There is a context free grammar, and he gave about the few statements about this context free grammar. This is very easy to everyone to remember which statement is true. So this statement is not only one, there may be multiple also. If you see the statement of this one, this grammar is ambiguous. When do you say the grammar is ambiguous? If there is a more than one parse tree for any sentence of this one, you can say that it is ambiguous. Definitely you can have the multiple trees for it. I tell you here, you take the tree A, S, B, then S. You write this as a just B and you make it as a epsilon. Ultimately a string W can be A, B, B will be coming here. We can substitute here. And this is also I written as a S, this is epsilon. If you take another one, S tends to AS, BS, I write it is a epsilon. I substitute, this is again BS, finally it is epsilon. Same sentence got the multiple trees here. So therefore it is a ambiguous grammar. Definitely AB will have here only one parse tree, but ABB is an ambiguous string. Yes, absolutely this is also true. So I can say that all these three statements are true. So this option is missing. We will see at the time of final key result, once revealed, then we will fill it up. These are the TOC questions as for this, based upon the memory. So definitely when complete paper is out, then we will provide the complete solution on the TOC. Thank you. Next chapter is going to be taken care by my colleague. So thank you. OS.
So as part of this GATE 2026 examination solutions, probable solutions, now we are going to deal with computer networks related questions. Look at this is the question statement from computer networks, like consider the implementation of sliding window protocol over a lossless link with a window size of n frames, where each frame is of size 1000 bits and bandwidth of the link is 100 kbps, where 1k is given 10 power 3 and one-way propagation delay is given 100 milliseconds. Assume that the processing times at the sender and receiver are 0 and the transmission time of the acknowledgement is also 0. Which options can give minimum window size required to achieve 100% utilization? So the question is clearly mentioned, the question statement is clearly mentioned, efficiency is 100%. So you know that as part of sliding window, okay, as part of sliding window, if efficiency is given as 100%, then what is the condition that you are having? W is equals to 1 plus 2a, right? Where you know a is equals to Tp by Tx. So Tp directly it is given in the question statement. One-way propagation delay is given 100 milliseconds. Tp is directly given. So Tp is 100 milliseconds. And Tx we need to find out. So regarding the Tx, what information we required? You know that Tx is equals to, which is transmission time is equals to frame size by bandwidth. So frame size, the question is clearly given, frame size is 1000 bits. This is what your L, right? So 10 power 3. It is 1000 bits. And the bandwidth is given 100 kbps. 100 kbps, which is 100 into 10 power 3. So as Tp is in terms of millisecond, better express this is also in terms of millisecond. Okay. So then it is coming to what? This is 1000 by 100. 1000 by 100. If you cancel 0, 0, so then you are getting what? 10 milliseconds, right? So this is what your 10 milliseconds. So Tx is 10 milliseconds, right? Tp is 100 milliseconds. So therefore, what is the A value? A is equals to Tp by Tx. So Tp is 100 milliseconds, Tx is 10 milliseconds, you are getting what? 10. So therefore, for efficiency of 100% in sliding window, what is the window size you have? W is equals to 1 plus 2a, which is equals to 1 plus 2 into 10, 20 plus 1, 21. So 21 is the answer for this first question, which is option A is the answer for this. Okay, right. So let's move to the next question. Yeah. So an ISP having address block of 202.16.0.0/15 assigns a block of 6000 IP addresses. So 6000 IP addresses to your client using the classless interdomain, like you can say Stridor notation. Okay, which of the following address blocks can be assigned by the ISP? So here, what is the block address? The block address is this one, which is 202.16.0.0/15, correct? So 15 is what? 15 is what? Your NID portion. So among these bits, the first 15 bits are NID portion. So 202 and 16, if I convert into binary, I can write 16 like this. And remaining all, I can write 8 zeros and again 8 zeros and at last 15, right? So now 15 bits are my NID portion. So from here to here, you can say from here to here, these are the 8 bits and these are the 7 bits. These are the bits are comes under my NID portion, and totally this is comes under your HID portion. Okay, but what the question is asking you, it is require 6000 IP addresses, 6000 host addresses. So if you want to have 6000 IP addresses, you know that 2 power 32 minus n is equals to 6000, right? So this is 2 power 32 minus what you can say, let's say if you consider this one also, directly you can have in terms of powers of 2. So what? 2 power 10 is 1024, 2 power 11 is 2048, 2012 or 2 power 12 if you consider, which is 4096, right? And 2 power 13 is what? Something it is around 4096 into 2, which is 8192, right? So 8192. So you required how many addresses? 6000 addresses. It means it is enough to have 13-bit host ID. It is enough to have 13-bit host ID. So, but here how many bits are host ID? You have 16 bits. So out of these 16 bits, you just consider only 13-bit host ID. So then, if you consider the 13-bit host ID for the requirement of 6000, so I am point outing with the green color. So this is what your 13-bit host ID. What is the 13-bit host ID? Here 8 bits and here 5 bits. So these are the bits now your host ID portion. If according to this 6000 requirement, if according to 6000 requirement, if these 13 bits are your host ID and remaining 19 bits are what? Remaining 19 bits are your NID portion. Agree? So which means the slash in all the options, the slash should be whatever the block you are going to allocate, that block mask or its prefix should be /19. So based on this, you can able to filter the options or not, you check. But unfortunately, all options are having 19 is the mask, so that we cannot filter the answer now. Then what is the further inspection we have to do? Host ID portion should contain all zeros, right? So means I need 13 zeros. My host ID portion should contain 13 zeros, right? So if you consider one by one option here. So first if you consider this option C. So option C here I believe it is 0, it is missed here, one more byte is missed. So if you see option C, 202.16 dot, so 202.16 dot 8 zeros and 8 zeros, correct? /19. Okay, so 13 zeros I required, 13 zeros, here 8 and here 5. So you require all are my zeros. So this is what my host ID portion. So this is obviously satisfying the requirement of 6000 IP addresses, right? Then coming to 64, if you consider the 64, so 64.0, if you convert this 64.0 into binary, what it is? So 202.17.64. How can I write 64? 01 000000 and 8 zeros, correct? /19. Now I required how many bits of host ID? 13-bit host ID in order to satisfy 6000 IP addresses. So all my 13 bits are zeros are not verified. Yes. So that this is also possible assignable block. This is also assignable block in order to satisfy these 6000 IP addresses. Then if you consider 32, so 202, 16, 32 if you write, this is the way how you can write 32. Dot 8 zeros /19. So last 5 digits if you check, these are the last 5 digits I am having, all are zeros, which is satisfying the 6000 IP addresses requirement. So that option D also possible assignable block. But when it comes to option A, which is 24.0, 24.0, how can I write? 24.0, 16 plus 8, right? So 16 plus 8, 7, 6, 5, 16, 8, right? So dot 0, 3 zeros and 8 zeros. Now verify. Last 5 bits, last 13 bits, if you verify, these are the 13 bits. Are these all zeros? No. Then this is not a possible assignable, or else assignable block address to satisfy 6000 IP addresses, because host ID portion should not contain all zeros. But among the remaining options, if you see, in all the options you are having last 13 bits, your host ID portion is having all zeros. So that your ISP can assign either this block or this block or this block in order to satisfy 6000 IP addresses. So that I hope this is an MSQ question. So if it is MSQ question, I can say the answer for this question is B, C and D. So B, C and D are the possible blocks in order to satisfy 6000, but R is not possible block. Okay, right. So let's move to the next question. So coming to this question, TCP connection which are always true. It is speaking about true. So option A, for connection establishment, TCP is using, see the question is asking about the TCP. For connection establishment, is it using two-way handshaking? No. So TCP for connection establishment, it is using three-way handshaking. So that's why I can say this is false statement. Now coming to option B, TCP is half duplex. No, TCP connections are full duplex actually. Reason, TCP is using pipelining concept and it is also using piggybacking concept. So that's why we can say TCP connections are full duplex. But here it is given half duplex, so that this is also false. Then coming to option C, both sender and receiver can initiate connection termination at the same time. So the question is asking about connection termination. So for connection termination, what concept you are using? Recall four-way handshaking, right? So in the four-way handshaking, like I have given an example also, wife and husband both can initiate termination at the same time because voluntarily they need to apply, right? Voluntarily they need to apply finish request. So that can be possible at the same time. So that is why we can say this particular statement is true. Okay. Then coming to option D, sender cannot initiate termination before receiver initiate. So I hope so this question is not MSQ, this is MCQ. Okay. This is MCQ. You know that these are all memory based questions, there can be some printing mistakes. So, but exact questions after getting the exact question paper, then we can see which is correct question, whether it is MCQ or MSQ. As it is memory based questions, I feel this is a MCQ question, so that option D if you check, sender cannot initiate termination before receiver initiates, which is false I can say. Reason, sometimes there is a possibility sender or a server can initiate termination before your server initiate. Reason, you know the TCP timer management, if you consider as part of TCP timer management, you are having persistent timer, you are having keep alive timer, you are having retransmission timer and time wait timer. If you recall that keep alive timer, so whenever the TCP is using keep alive timer, then what will happen? Connection is established, but no data transmission from client, and server keep on waited for the client, but client is not responding, then server itself can initiate the connection termination because no use of the connection establishment by the client, because the client is dead or else the client is been not using the channel at that time. So that's why we can say option D can be possible false statement, right? So overall, what is the correct answer for this question? I can say option C. Then coming to this question, so this question I hope so equals to the first question itself, I believe, right? So this question is already been covered. This is the first question, okay? What is the answer for this question? 21. It is shortened type. So this is what your computer networks related questions. So in continuation of this, I would like to complete this operating systems questions also. So if you consider the questions from operating system, so these are very usual questions. Operating system questions are very usual questions. You can say based on deadlock, you are having two questions. One is numerical, another one is theory. So let me write the question statement. One question based on deadlock. This is an MSQ question. This is an MSQ question. So number of processes it is given 5 and demand of each process is 2. Then the question is asking number of resources to ensure the system is free. the system is deadlock free. This is what the question in a simple format. Okay, so you know that there is a formula we have. What is that? Demand of all processes must be always less than the number of resources plus the number of processes. Do you remember this? So now demand of each process, total how many processes you have? 5. Each process is having demand of 2, so that what is the total demand? 10 is less than number of resources we need to find out. Let's say the number of resources I am taking as m plus number of process it is given 5. Then how can I write this one? 5 is less than m, or you can also consider m is greater than 5. So m is greater than 5. So greater than 5, what are the values I am having? 6, 7, 8, 9, right, and so on. So among these, this is the minimum value of m, right, minimum value of m for which the system can be free from deadlock, for which the system can be minimum value of m for which the system can be free from deadlock. So the question is asking about deadlock free. So that what should be the answer? 6. So for this question I can say 6 is the answer. Okay. So then this is not I don't know exactly, but whether it is MCQ or NAT, but answer for this question is 6. Then coming to the next question, there is one more question we are having from deadlock. So this is MSQ, this is also MCQ question, I can say. What are the options it is given? So this is MSQ question, okay, MSQ. What are the options it is given? Which of the following is or true, is or false, right? Is or false with respect to deadlock. Which of the following is or false with respect to deadlock? Option A, it is given assignment edge in resource allocation graph is marked from process P to resource R. Option B, a safe state guarantees that all processes can finish without formation of cycle. A system is guarantees that all systems can finish without formation of cycle. Safe state, that is safe state, right? Option C, deadlock formation can be prevented by ensuring that hold and wait condition is not allowed. Then option D, it is given Banker's algorithm. Banker's algorithm is used to prevent the deadlock. So these are the options are given. So we need to find out the false statement. Mind this, okay? So first concentrate on the option A, assignment edge. You know that assignment edge is also called as what? Allocation edge, right? It is also called as allocation edge. Allocation edge in the resource allocation graph is marked as process to resource? No, right? It is reverse, no. Allocation edge means what? Resource to process, but not from process to resource. If it is process to resource, then what it is called? Request edge, but not allocation edge. So, but the question is given assignment edge in resource allocation graph is marked from process to resource, which is false. So, option A is false. Then option B, a safe state, see this is what the critical word, a safe state guarantees that all process can finish without formation of cycle. Yes, safe state is always what? Deadlock free state, right? No cycle. This is true. Then option C, deadlock formation can be prevented by ensuring that hold and wait condition is not allowed. Yes, you can say that this is true. Deadlock prevention can be prevented. So this is true, right? Because you know that in order to occur the deadlock in the system, we are having 4 necessary conditions like mutual exclusion, hold and wait, circular wait, and no preemption, right? So if any of these conditions are occurred simultaneously in the system, then we can say there is a deadlock in the system. If any one of these are not occurred, means either hold and wait or circular wait or no preemption or mutual exclusion. If anyone is not occurred in the system, then we can say there is no deadlock, means deadlock is being prevented. So here deadlock formation can be prevented by ensuring that hold and wait condition is not allowed. Yes, which is true. By dissatisfying hold and wait, we can prevent the deadlock. Correct. True. Then option D, Banker's algorithm is used to prevent the deadlock. No, Banker's algorithm is basically used for what? Avoidance, right? It is used for avoiding the deadlock, right? It is having 2 variations. I am speaking about Banker's safety algorithm. Banker's safety algorithm we are using in order to avoid the deadlock. Banker's resource request algorithm we are using in order to detect the deadlock. But the question is speaking about prevent, which is wrong, right? So this is false. So overall, if you see, the question is speaking about false. We need to find out the false with respect to deadlock. So among these 4 options, A and D are the false. So that the answer for this question is A and D. Okay. Then coming to next question. So there is a question from fork, something like code is given for I is equals to 0, I less than 3, I plus plus, and then we are having if clause. After entering into the for loop, we are having if clause. Within the if clause, we are having fork is equals to 0. Continue, continue, else what? Break. Okay, else break. And this is what your for loop statement. After for loop, we are having printf statement. So printf hello. So now look at this. If you consider this is the question statement, initially I am having process P0, which is my parent process. Process P0 is executing with is starting its execution with I value is equals to 0. And then it is coming to here 0 is less than 3, condition is true, so that enters into for loop. So process P0, which is my parent process, which is entered into the for loop now. After entering into the for loop, I am having if clause fork. When there is a fork, what this parent process P0 is doing, it is creating a child process. So when it is created child process, you know that fork is returning value 0 to the child process and positive value or else child process ID to the parent process. Then means it is positive value, correct? Obviously it is more than 0. So now this particular if clause can be satisfied by whom? Is it by the parent or is it by child? Obviously it is going to be satisfied by the child, because the return value to the child is what? 0, but it is positive, no? So parent is skipping this if clause. If it is skipping the if clause, then it is entering into the else block and then break. It means the parent is being not entering into this if clause overall, it is entering into the else and then it is coming out of that. And then it is printing hello for first time. Then in the meanwhile, I am having child process now P1. What this P1 is doing, it is continuing in the sense again it is iterating. Now P1 is iterating and its I value, previously it is 0, now it is making I value is 1, then it is again coming to this condition. Then for P1, 1 is less than 3, which is the condition is true, then P1 is entering into the if clause. Then this P1 again executing this fork, what will happen? This P1 is printing, this P1 is creating P2 now, right? P1 is creating P2. And by the time P1 is acting as the parent, for this it is having positive value, and this is the next child process. This is the next child process which is having 0. Now for P2 it is going to be true, but for P1 it is going to be false, so that P1 can enter into the else block, so that P1 also going to print this hello, right? This hello. In the meanwhile, what this P2 is doing, again it is continuing. So now again it is continuing, now it is making I value is 2. So with I value is 2, again it is coming to 2 is less than 3, condition true, so that it is coming to here, fork. Now this P2 is executing this fork statement, which is creating P3, child process. By the time this P2 is becoming parent, so that for this the return value is positive, and for this the return value is 0, right? So now P3 can be executed, right? P3 can be executed, and for this P3, this if clause condition can be true, but for P2, because it is a parent to the P3, no. So now P2 is skipping the if clause, but P3 is entering into the if clause. Then this P2 is coming to printf statement, and it is printing hello. By the time this P3 is entering into the continuation. So if it is continued, then I value is 3, but what will happen? 3 is less than 3 condition is false, so that P3 directly will come to this printf statement. So which means P3 also can print this hello. So overall, this hello can be printed for how many times? In the sense 4 times. So 4 times how? 3 times of child process and 1 time of main parent process. So overall, 4 times this hello can be printed. So 4 is the answer for this question. So then coming to next question. So this is a little tricky question and conceptual question. I cannot say this is tricky, conceptual question. So here it is given TLV, it is given cache, and it is also given MMU with paging. So you have implemented paging concept using all these 3. Means you can say page table is being used, page table is being used, cache is being used, and TLB is also used. And what is the exact question? Which is never be true? Which is never be true, right? Never be true. Never be true in the sense what? False. Mind this. So we need to find out the false, right? Options are given like this. What are the options? TLB miss, page table hit, TLB miss, cache hit. Then option B, TLB miss, page table miss, cache miss. Then option C, TLB miss, page table miss, cache hit. Then option D, TLB hit, page table miss, okay, page table miss and cache hit. So verify among these options. So the question is asking about paging is being implemented using all of this. Mind this one point here. TLB is the cache of what? It is the cache of page table, correct? And cache is the cache of what? Main memory, correct? So TLB contains most frequently referred pages along with their frame numbers. Cache contains the most frequently referred, you can say, data and instructions. So that is the basic difference between TLB and cache. So it is having pages and frame numbers. It is having what? Instructions and data, right? So that is what basic difference between them. So now as paging is implemented with all, okay. So first let us check with the option D. If you see option D, what it is doing? TLB hit is occurred. Okay, TLB hit in the sense, what is the entry format of the TLB? TLB entry format is what? You can say page number and frame number. Page number and frame number. I got the frame number because TLB hit is occurred. I got the frame number. If I got the frame number, then page table miss is happened. No, reason page table contains all pages information. From that, you are having frequently access to pages are part of your D. Then how? If TLB hit is there, page table hit miss, how it is possible? Because page table is having all pages information. Among those pages, frequent pages information is part of the TLB. So that's why you can say option D is false here. Okay. Then coming to option C. TLB miss, page table miss. TLB miss, page table miss. So if TLB is miss, then I am going to page table, correct. If page table is also miss, what does it mean? No frame number. If no frame number in the sense, it is not part of the main memory. But here it is given what? Cache hit. How it is possible? Am I correct or not? So page table is having miss. Page table generally contains all pages information along with the frame numbers. But that page table does not have that information. Then how the cache can have? So that is why this particular statement is also false. So the same pattern, you apply this concept with respect to option A and option B. These are the true here, right? So these are the true. So TLB miss is there, then page hit is there, and cache hit can be there, right? It can be possible, no? So if TLB miss is there, then what does it mean? I can go to page table. If I go to the page table, obviously I can get the hit. If I get the hit, then that particular frame number can be or may not be part of the cache hit. Cache, am I correct or not? It can be or it may not be. So that is why I can say it is true. So similarly this one, okay? So overall I can say, as it is asking about what? Never be true, which is false, right? So the answer for this question is C and D, okay? So these are the questions from operating systems and CN subjects. I can hand over the session. Next, COA faculty, YV Ramaya garu. Thank you.
Good evening to all. Here, in regular classroom, physical class and online class, what we have discussed, the most of the points and questions were displayed in the morning session paper. At the same time, while discussing our subject, while starting our subject, I gave brief introduction regarding which topic is more important, like that. Here also, same thing was displayed in the morning session. Here, on pipeline, one question was there. On computer arithmetic, 2 questions were there. On memory organization, especially tag field, 1 question was there. Next, on secondary memory also 1 question was there. Next, on addressing mode also 1 question was there. On IEEE floating point representation, 1 question was there. And on overflow also we had 1 question. According to the information what I have collected from our reliable resources, we are going to make discussion here, and at the same time we continue the discussion once again after getting the official paper from respective IIT. Let us start the session. COA. Next, at the same time, our subject weightage this year, morning session paper. COA weightage is around, means approximately 10 marks. Simply 10 plus marks. 10 plus marks. Let us start the discussion of our questions. First one, watch this. Which one of the following dependencies among the register operands of different instructions can cause a data hazard in pipeline processor? It is a very simple question. According to the majority students' opinion, this question was given in MCQ format. Now look here, read after read, also known as a no dependency, because reading operation doesn't make any change in the source register content. That's why it is also known as no dependency. Read after write, true dependency. Generally, current executing instruction depends on the result of its earlier instructions. That's why truly it is happened. That's why it is known as true dependency. To prevent this, to resolve this true dependency, we use either NOP instruction, means compiler approach, or operand forward. At the same time, write after write, also known as output dependency. Next, write after read, anti-dependency. In classroom also, in classroom notes also, I gave these points clearly. Here, C and D means WAR and WAW can be resolved by using register renaming, but not possible to resolve this one directly. Which one? Read after write. Read after write means true dependency. Read after read means no dependency, because reading operation doesn't make any change in the source register content. That's why for this question, here correct answer is A only. Read after write means first perform writing operation, result writing in the earlier instruction, then only it is possible to perform read operation of that result. First question. Next, come to next question. Consider the real value variables x, y and z represents using IEEE 754 using single precision floating point format. The binary representation of x and y in hexadecimal notation are as follows. Let z is equal to x plus y. Which one of the following is the binary representation of z in the hexadecimal notation? It is a very simple question. Direct question it is. We discussed so many such type of questions in class also. X is nothing but. These are given in hexadecimal. Convert the same thing into binary. While making conversion from hexadecimal to binary, each hexadecimal digit requires 4 bits. So, X is nothing but 3, 5, C, 5 zeros. Here, Y, 3, 4, A, 5 zeros. Here we conclude one thing clearly. X is positive data, Y is also positive data, because 3 means 0, 0, 1, 1 means MSB is equal to 0. Then automatically result is also positive because of that reason. Here we cannot remove any option. Next, look here. Find the X value and Y value. X is nothing but 3 means 0, 0, 1, 1, 5 means 0, 1, 0, 1, C means 1, 1, 0, 0, remaining all are zeros. Its value is like this. In this 32 bits, it is sign of the data. Next 8 bits are used to represent biased exponent. 1, 2, 3, 4, 5, 6, 7, 8. Its decimal value is 1, 2, 4, 8, 16, 32, 64 means biased exponent value is 107. Already we know biasing value is 127. That's why true exponent value is minus 20. It is nothing but mantissa. At the same time, expression value is, what about expression value of X? Nothing but minus 1 whole power S into 1 point M into 2 power small e means true exponent. Here it is nothing but, look here, 0 means it is positive, not needed to write. 1 point, what is mantissa here? Mantissa is nothing but 1, remaining all are zeros. Next, into 2 power minus 20. It is X value. Y value is like this. Y value. In this, if you find Y value, if you want to find Y value, 3, 4A, 5 zeros. 3 means 0, 0, 1, 1, 0, 1, 0, 0. A means 1, 0, 1, 0. Remaining all are zeros. S, E, M. Capital E represents biased exponent. Value is 1, 2, 4, 8, 16, 32, 64. Means it is nothing but 105. Then small e value is nothing but minus 22, because biasing value is 127. It is nothing but M value. Because of that reason, its value is, apply the same, minus 1 whole power 0 means 1, means 1.010 like this into 2 power minus 22. This exponent is minus 20, this exponent is minus 22. If both are same, we can perform addition operation directly. Because of that reason, here it can be written as 0.0101000 into 2 power minus 20, means you have to shift the decimal point to left. Then automatically, what happens? Exponent gets increment. Now, in this, if you want to perform addition operation, what is X here? 1.1000 like that into 2 power minus 20. Y value 0.01010 into 2 power minus 20. When exponents are same, then it is possible to perform addition operation directly. 1.1110 remaining all are zeros. You have to produce these values in IEEE format. It is nothing but Look here. If you produce these values in the IEEE format, here it is nothing but S, E, M. S is nothing but 0, Y sign is 0. Here M value, here M value is this one, 1, 1, 0, 1, 0, 0, 0, remaining all are zeros. M size is 23 bit and capital E size is 8 bit. Here what is capital E value here? Nothing but minus 107, minus 107, that's why capital E value is nothing but 107, means 128, 64, 64, 32, 96, 16 not needed, 8 is needed, 4 is not needed, 2 and 1 are needed. Here 1, 2, 4, 8, 11, 11 plus 96, 107. Here convert the same thing into hexadecimal, nothing but 3, nothing but 5, nothing but E, 8, remaining all are zeros. That's why our answer is 3, 5, E8, 0, 0, 0, 0, H. Correct option is A. Okay. Next, come to next question. Here, this question is given on addressing modes. Very simple question it is. The classroom notes is enough to solve this question. Immediate addressing mode, indirect addressing mode, base with index, base with offset displacement. Immediate addressing mode means instruction uses the constant, means immediate value. So P is equal to 4. Next, indirect addressing mode. Here, processor uses stack memory, not with direct addressing mode, indirect addressing mode, also known as auto increment and auto decrement. That's why here stack memory uses the stack pointer. So Q is nothing but 2. So P4, Q2. It is available only in option D, not needed to make further discussion. If you make further discussion, index value, index addressing mode is used for implementing array. I explained that point clearly in the class. That's why R is equal to 1. Next, base register addressing mode, elements of record. That's why correct option is D. Simple question it is. Come to next question. It is excellent question based on magnetic hard disk. Now look here. Just I am going to provide overview for this. Consider a hard disk with rotation speed of 15,000 RPM. Given RPM is nothing but 15,000. Next, RPS, nothing but 250 RPM by 60. Then one rotation time is nothing but 1 by 250 means 4 millisecond. Then average rotational delay 2 millisecond. Next, look here. The time to move the head from a track to its adjacent track is 1 millisecond. Whatever the current position of the head, to move from current position to current track number to next track number, either upper track number or lower track number, it takes only 1 millisecond. Initially the head is on track 0. The number of sectors per track is 400. The sector size is 1024 byte means 1 kilobyte. It is necessary to transfer data from 10 randomly located sectors in each of the following tracks in the order of first 5, next 12, next 7. In this order only. The total time for data transfer in milliseconds from the hard disk is dash. Here, first of all, head is positioned at which track number? Track 0. First of all, To move from track 0 to track 5, compulsory seek time is needed. Look here. File transfer time is nothing but seek time, file preparation time, plus rotational delay, plus read or write means transfer time. So in this, first of all, to transfer 10 sectors data from track 5, first of all, T5, from T5, seek time 5 milliseconds. Why? To move from track 0 to track 1, 2, 3, 4, 5, plus rotational delay is needed. That's why you have to take the average rotational delay. That's why, because sectors are not in sequential manner, random manner, the average rotational delay is 2 milliseconds plus 2 milliseconds for each sector. How many such sectors are needed? 10 sectors plus later transfer time. Transfer time of each sector is like this. What is one rotation time? Sorry, 4 milliseconds. One sector reading time is 4 milliseconds by number of sectors present is 400. It is nothing but 0.01 millisecond. That's why it is nothing but 0.01 milliseconds for one sector. How many such sectors? 10. So finally, what about our answer for T5 is nothing but to read the data from T5, 25.1 millisecond. After completion of T5, again it goes to T12. So how much time is needed for seek? T7. 5 to 12 means 7 milliseconds plus again the average rotational time is 2 milliseconds into 10 plus these things, all these things are same. It is nothing but 27.1 millisecond. Next, after that, 1 minute, after completion of T5, it goes to T12. That's why we require 7 milliseconds. Later, after completion of T12, it has to come back to T7. To come from T12 to T7, again it requires 5, 6. So 5 millisecond plus this information is same, nothing but 20 millisecond plus nothing but 0.1 millisecond. So finally, this answer is 25.01 millisecond. So entire file transfer time is 27.1, 25.1 plus 25.1, nothing but 77.3. If question is given in this format, our answer is like this. If any change is there in question, we can discuss the same after getting the official paper. Come to next question. Now it is a very, very, very important question. Sorry for this. Load store architecture, register based architecture, instruction format. First operand is destination. First operand is destination and remaining two operands are source. What is the meaning of that? If question is given like this, it is the destination, remaining two are source. If instruction is given like this. Here z is equal to x plus y, where x, y, z are memory operands, R0, R1, R2 are registers. Look here, x, y, z are memory operands, means those are stored in memory. Here, in this, what is the correct option? load and store instruction, these are used in RISC processor. In RISC processor, processor visits memory only for instruction loading and result storing, and it is designed with multiple processing registers. Because of that reason, processor uses the registers for storing intermediate result, and at the same time, it is impossible to, look here, in RISC processor, in RISC architecture, load and store architecture belongs to RISC. ALU operations are performed between only processing registers. So, to perform any arithmetical operation, first of all, these operands are needed to place in processing register. That's why, look here, first of all, X is needed to read from memory, Y is also needed to read from memory to where? To registers. Look here, load R0 comma X. First memory operand is placed in R0. Load R1 comma Y. Second memory operand is placed in R1. Add R2 comma R0 comma R1. X and Y are added. Result is placed in R2. Finally, R2 is placed in Z, means memory address. Means processor uses memory only for storing the result. That's why correct option is A only. Excellent question it is. Already I gave clear explanation regarding RISC and CISC processors in both online and offline. All these entire information is available in our classroom also. Next, along with these questions, I have collected some more questions from from reliable sources. I am going to discuss those questions also. Just look here. On overflow. Here, he gave X and Y values like this, X 10, 110, 100, Y 01, 00, 1100. These are expressed in signed magnitude format, not 2's complement, signed magnitude format. At the same time, which of the following operations result overflow? It is nothing but MSQ. Which of the following options results overflow? It is the question, watch question. And at the same time, options are like this. We discussed so many number of questions on overflow in the regular class, but we discussed on 2's complement. He mentioned on signed magnitude. There is no change in the concept except the range provided by the signed magnitude notation. Nothing but X minus Y, X plus Y, minus X plus Y, next minus X minus Y. Here, if you watch this one, size of the data is 8-bit. So, in signed magnitude notation, 8-bit data range is between minus 127 and plus 127. When result is beyond this range, overflow occurs. Already we know the same. Now in this, first you find the decimal value for the same. What about X decimal value? X decimal value. It is nothing but it is negative 1, 2, 4, 8, 16, 32 means minus 52. If it is expressed in signed magnitude, no complement is needed. Next, at the same time, y value here positive means 1, 2, 4, 8, 16, 32, 64 means 64, 72 plus 4, 76 means plus 76. Then, what is option A? X minus y. What is option A? A is nothing but minus 52 minus 76 means minus 128. Yes, overflow occurs because it is beyond the range. Come to next one, option B. X plus y. No overflow occurs because after adding one positive value or negative value, no overflow occurs. Next, minus x plus y. Here minus x means 52. See, minus x 50 minus 52 plus 52. Next, plus y plus 76, nothing but plus 128 means overflow occurs. Minus x minus y. Why option D is wrong? Minus x means minus of minus 52 means plus 52 minus 76 means minus 22 means no overflow occurs. So correct options for these are for this question A, C. Next, last question in this, based on the tag field computation, we discussed clearly regarding the tag field computation in regular class. Excellent question it is. The concept what I have explained, what we have discussed in the regular class is enough, and if you apply that concept, minimum amount of time is sufficient to solve this question. According to this question, catch concept on tag field size computation. Here, before going to start the question, better to remember this one. If you have any doubt, better to watch our classroom notes also. For n-way set associative cache, tag size is means tag field size is what I told here, PA minus CA plus log n. What is n here? Associativity. PA minus CA provides the direct mapped cache tag size. First find the direct mapped cache tag size plus log n here. If you are clear in this, it becomes very easy to solve the given question. This information is enough to get solution for the same. Look here, question is given like this. Main memory size given is nothing but 2 power 23 byte. Cache memory size, given cache memory size is 2 power 13 byte. Next, block size is 128 byte. From this information, according to our style, PA physical address size is nothing but 23. CA cache address size 13 means for a direct mapped cache, tag size is PA minus CA nothing but 10 bit. At the same time, two organizations are there. What about first organization, direct map? According to given question, there are two organizations, means two types of cache designs. First one, direct map. Second one, K-way set associative, not N-way, K-way set associative. If it is direct map, tag field size is 10 bit. At the same time, here K is equal to 2 power L. What is K here? Associativity 2 power L. What is L value here? L is nothing but 1, 2, 3 and so on. Here, if you watch the question, which of the following relations? Which of the following relations between N and M is correct? Here, what is M here? You should understand what is M here. Here M is nothing but direct map tag field size. What is M here? M is nothing but direct map tag size, tag field size. Here, what is N here? M means M bits. What is N here? N is nothing but N bits. K-way set associative. Tag field size. Already we know simply. What about K-way set associative tag field size? Nothing but PA minus CA direct mapped means M plus. It is nothing but here N. N is nothing but M plus log K. What is M here? According to our style, PA minus CA direct mapped cache tag field size. So, but here, what is K here? Given K. If you know this one, this information is enough to get the solution for the same. Now, what is K value here? According to given information, here L is nothing but 1, 2, 3, K is nothing but 2 power L, means associativity nothing but 2, 4, 8, 16 like that. That's why. Very simple and very clear. If you watch the options, in this, not needed discuss options, in this, it is nothing but N is nothing but M. N means tag field size in K-way block set associative mapped cache. Nothing but tag field size in direct mapped cache plus log K means what is log K here? Log K with base 2, nothing but L. Why L? Log K means log 2 power L, nothing but L. So, what is correct answer? It is the correct option. It is given in the 4 options. So, correct option is this one. So, a student who is very strong in, who understood this expression clearly, he can able to solve this question at shortest time. And next, our Srinivas sir is going to continue our DS, data structure and algorithm.
Hello everyone, welcome to ACE Engineering Academy. So today I am here to discuss GATE CS 2026 questions based on data structures, algorithms and programming questions. Okay. So one question asked from heap tree, as I mentioned in the classroom also, compulsory topics which they will ask in the GATE, heap and then sorting, minimum cost spanning tree. Right friends, okay. So as usual they ask question from spanning tree as well as heap concept. Okay. So this is a question C, consider a heap containing n elements where n value is greater than 100. They mentioned n value is greater than 100. And one more condition they provided, n is odd number. N value greater than 100, n is odd number. Then assuming 1 based indexing, means array index is starting from 1 instead of 0. Then which are the following cannot be, they are asking, cannot be the index of leaf node. Which are the following is cannot be the index of leaf node. Clear friends, okay. Just recap our class notes concept which we discussed. Suppose if array index is starting from 1, array index is starting from 1 and if it is ending at n, there are 2 points I mentioned clearly in the class notes. The first point is highest index of non-leaf node. Highest index of non-leaf node is floor of n by 2. This is highest index of non-leaf node. Whereas leaf node index starts from floor of n by 2 plus 1, it will be ended at n. Is it clear friends, okay? Leaf node index starts from floor of n by 2 plus 1 ended at n. Now they are asking which of the following cannot be the index of the leaf node. If you look at here, obviously n is a part of leaf node index, right friends, okay? Even it is n plus 1 by 2 which is also part of leaf node index because these are leaf node indexes friends, okay? So therefore C is leaf node index and D also leaf node index. Whereas if you consider n minus 1 by 2, obviously n minus 1 by 2 compulsory less than or equal to n by 2 only, right? N minus 1 by 2 less than or equals to n by 2, which is the highest index of the non-leaf node, okay? So therefore it is also less than or equal to n by 2. So therefore these two are index of internal node but not leaf node. So they are asking which of the following cannot be the index of leaf node. So these two are cannot be the index of leaf node. I hope you answered the same thing, right friends, okay? Yeah, this is a programming based question. If you just recall our class notes, I explained simple loop questions, right? Different models. If you look at first part of the function, in the first part of the function, it is written 1 plus bar of n by 2. It is written 1 plus bar of n by 2. Just recall how we construct recurrence equation for this problem. Suppose if the input is n, then the time required for executing this program we have defined it is t of n, right friends, okay? So with this input n I am entering into function body one time, therefore I can count it as one function call. After one function call, input value becomes n by 2, therefore the time required to execute this one is t of n by 2. This is the way I explained, right? T of n by 2. This is the recurrence equation for this problem. And also it is a recurrence equation for binary search also. Just recap all things, okay? So what is the time complexity of binary search which I explained here in the class? It is approximately log n base 2 under theta. Log n base 2 under theta friends, okay? So that is the time complexity of binary search. In the same way, this algorithm is also taking 1 plus t of n by 2 that equal log n base 2. I covered this problem in simple loop concept also, okay? So we solved here by using recurrence equation. It means that if I call bar int n, it is taking log n base 2. If you want to strictly ask me what is taking, I can say it is floor of 1 plus log n base 2. Anyway, we are taking approximation values, not exact values. Therefore, I am not focusing on exact results, okay? I can strictly say it is floor of log n base 2, right friends, okay? Now come back to here. Here there is a function FOO which is defined like this. Whenever n is equals to 1, this function returns 1. If n value greater than 1, it is calling 1 plus foo of bar of n. Means FOO is calling bar of n friends, okay? Fine. You understood that bar of n always returns log n. Bar of n always returns log n. So what is the question asked in the paper? What is the smallest value of n? We need to find smallest value of n, for which foo of n is equals to 5. Means for what value of n, foo of n becomes 5 friends, okay? We don't know what value of n, foo of n equal to 5. So what we will do, just observe friends. We want to make it as foo of n is equals to 5. I want to choose the smallest value of that, right? Smallest value of that. So with that 5, if I enter into the function body, just I am entering the function body. Then n is equals to, definitely it is not is 1, it is not equal to 1 because I am expecting smallest value of n which satisfies this condition. Anyway, our analysis is only for large values of n. So therefore, it cannot be n equal to 1. If it is n equal to 1, it is directly written 1. But our answer is here 5. So therefore, whatever input you are providing here, with this input we enter into this function body. After checking base condition, it is taking 1 plus, means it is taking 1 plus FO of, it is calling bar of n, right friends, it is calling bar of n. So the moment if I call bar of n, okay, the moment if I call bar of n is giving value is equal to how much? Log n base 2. So its written value is equal to log n base 2. Therefore, it is taking FO of log n base 2. Is it clear friends? FO of log n base 2. So FO of log n base 2. Is it clear? So that is her first iteration. If I continue further, if I go one more iteration, so remember this one is already there. If I go one more iteration, it is taking 1 plus again FO of, earlier we have n becomes log n base 2. Now we are having log n, again that log n will be reduced to log of log n base 2 friends, okay. So that is log of log n base 2. Is it clear friends, okay. Means the right hand side I am expecting result equals to 5. Right hand side I am expecting result equals to 5. Maybe it is not visible here, okay, let me write properly. Continuation, this one I am writing here 1. If I call this function again, it is taking 1 plus FO of log base 2 of log n base 2 friends, okay, log n base 2, that is equals to 5, right friends, okay. So one more time if I call, obviously here 1 plus 1, we can rewrite this 1 plus 1. This if you call one more time, I can say it is 1 plus FO of, again it is taking log base 2 of result, whatever result we are having that result. Means if it is n, it is reduced to log n. If it is log n, it is reduced to log base 2 of log n base 2. So log base 2 of log n base 2. This total result must be equal to 5. I want to choose that type of value friends, okay. But how long I need to call? I need to call until this value must be equal to 1. Because if this value equals to 1, so whenever n is equal to 1, this function returns 1. So if this function returns 1 means how many ones must be added here? 4 times 1. Therefore, I am calling one more time 1 plus 1 plus 1 plus 1 4 times, okay. So this function one time, and here it is taking FO of log base 2 of, again log base 2 of log base 2 of log base 2 of n is equals to 5, right friends, okay. So here already we are having 4 ones. If this result is equals to whatever we are having, if this result equals to 1, then whenever n is equal to 1, it returns 1, right, okay. So 4 plus 1 that equal 5. Therefore, I want to choose value of n, such that this total value must be equals to 1. Now, what value of n it becomes 1? You think logically, if it is n is equals to power of 2, what value of power of 2? This total value equal to 1 friends, okay. Simply you can take n is equals to 2 power, you can take n is equals to 2 power 16 friends, okay. The moment if you take n equal to 2 power 16, it is 2 power 16, bring 16 here, log 2 base 2. So log 2 base 2 becomes 1. Now we have 16 we can write 2 power 4, bring 4 here, log base 2 1. It is 4, we can write 2 square, bring 2 here, log 2 base 2, that is also 1. Finally, it is FO of 1. FO of 1 value is equal to how much friends? 1. So this is 1, and already we are having 4 ones, 4 plus 1 that equal to 5. Therefore, the smallest value of n which I can choose to make it equal to 5 is 2 power 16. So this question directly asked from the class notes by using simple loop as well as recursive algorithm which we covered in the class friends, okay. Very simple problem it is. Yeah, this question based on master theorem concept. So they provided two functions friends, two recursive functions. T1 of n is equal to 4 times of T1 of n by 2 and T2 of n. What is T2 of n? T2 of n equal to 5 times of T2 of n by 4 plus theta of log n base 2, log n base 2. So I remembered the question like this only, okay. If it is a question, then what is the correct answer? First evaluate T2. Just apply master theorem which we covered in the class, okay. Just apply master theorem here. It is nothing but A is equal to, if you compare the master theorem, A value is equals to 5. Hope you remember the master theorem structure. T of n is equals to A into T of n by B plus theta of n power k log power p n to the base p. So this is the master theorem structure we covered, right friends, okay. Here they provided T2 of n is equals to T2 of n equal 5 times of T of n, T2 of n by 4. So 5 times of T2 of n by 4 plus it is nothing but theta of, I think this value is equals to log n base 2. Okay, it is didn't prepare printed properly. It is log n base 2. Now just compare this, what is A, what is B, what is K friends, okay. Now just by taking this value, A is equals to 5 and B is equals to 4, it is n power 0, right? We can write n power 0. So when it is n power 0, K value becomes 0 and P value equals to 1. Just verify, is A greater than b to the power of K? A greater than b to the power of K. Yes, it is A greater than b to the power of K. Hence, it is the first case of master theorem which we covered in the class notes, okay? Which we covered in the class notes. According to class notes, if case 1, therefore, the result must be equal to T2 of n is equals to formula theta of n to the power of log A base B friends, okay? Log A base B. What is A here? 5. B means here 4. Log 5 to the base 4. Therefore, this result whatever we are having, that result is equals to theta of n to the power of log 5 base 4. Then by substituting that result, this equation becomes T1 of n is equals to 4 times of T1 of n by 2 plus this result equals to theta of n to the power of log 5 base 4 friends, okay? Log 5 base 4. Again compare the master theorem. Here A is equals to 4, A is equal to 4 and B is equal to obviously 2, right? B is equal to obviously 2. It is n to the power of K format. This is called K friends, okay? N to the power of K format. What is K value here? K is equals to log 5 base 2. K equal to log 5 base 2. If it is log 5 base 2, it is more than 2 only, right? So it is something like 2 point something. 2 point something. Just imagine like this, because we are finding only approximation values. Asymptotic analysis always approximation values only. That's why it is 2 point something friends, okay? A equal to 4 and B equal to 2. Now verify, is A less than B to the power of K or not? A less than B to the power of K or not? What is A here? A equal to 4, 4 less than, B value equal to 2 and K value equal to 2 point something. Yes. 4 less than 2 to the power of 2 point something. So whenever A less than B to the power of K, it becomes case 3 of master theorem. Have you remembered case 3 of master theorem friends? Case 3 of master theorem is mentioned. Solution for this one is theta of T of n equal to whatever portion is there here, that is the answer for that question, right? Have you remembered master theorem? So therefore, this is the correct answer for this question. And finally, this result must be equal to theta of n to the power of log 5 base 4 is the correct answer for this question among the given 4 options, friends, okay? Just we applied master theorem 2 times. This is also discussed in the class, friends, okay? You believe me, whatever questions asked in today paper, all questions directly came from class notes with only small modifications, friends, okay? Yeah, this question based on binary tree concept, okay? So look at here, elements starting from 1 to 15 are given and can be inserted in any order. They can be inserted in any order, right friends, okay? But a binary search tree is required to be complete binary search tree. Actually, these elements are inserting into binary search tree, but that binary search tree is forming complete binary search tree. Complete binary search tree. Of course, they mentioned a complete binary tree, but after taking a pattern of binary search tree, it will become complete binary search tree only. So 15 nodes, how we are writing complete binary tree? You know, right? So 15 nodes if we have, we can draw a complete binary tree in this structure. While I am discussing trees concept in the class, this is the first diagram I explained in the class, friends, okay? It is a complete binary tree which is having 15 nodes. Right, 15 nodes. But it must satisfy binary search tree structure also. See, elements are starting from 1, ending at 15. I can write elements like 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10, 11, 12, 13, 14, and then 15, friends. They are elements. If you observe this tree structure, left subtree contains exactly 5 elements, correct? Sorry, left subtree contains exactly 7 elements, and right subtree also contains exactly 7 elements. And also it must maintain binary search tree structure. Then tell me who is the root node, think logically. So the root node must be is equals to, so I can say 8 is the root node, such that left subtree we are having 7 nodes and right subtree we are having 7 nodes. Therefore, the pattern of inserting it is 8 here, friends, okay? Afterwards, in order to get 7 nodes here, which node I have to insert? Very simple. So total 7 nodes are there. You can take middle element, that equal 4. to maintain binary structure. So therefore it must be 4, right friends, okay. Similarly, we are having 7 element, take middle element, that equals to 12, right friends, 12. So therefore, if I am talking about insertion point of view, it is 8, 4, 12. What about next? In these 3 nodes, in order to arrange these 3 nodes, definitely this node is the middle element as the root node of the subtree. So I can take 2 and it is 1, 3. And for this one, middle element is the root node of that subtree. So therefore I can take 6, here it is 5, 7, so that is a binary subtree. Here I can take middle element as the root node of that subtree. So 10, 9 and 11. Afterwards, we can take 14 here. So it is 14, 13 and then 15. Actually, what is the question they asked here? Which of the following elements will never be the third element? Third element in the insertion order they mentioned. Will never be the third element in the insertion order, friends, okay. They provide options are like this. First option 2, second option 10, third option 4, okay, and fourth option something like 6, okay. So which of the element, which of the following elements will never be the third element? Never be the third element. For example, friend, if I insert in this order 8, 4, 2, 8, 4, 2. 8, 4, 2, obviously third element which I inserted is 2. Therefore, I can eliminate option A. So, to eliminate 10, if I insert in this order, first I filled 8, afterwards I filled 12, then 10. Obviously, the third element which I inserted, right? Therefore, I can eliminate B also. Then what about 6? If I go like this, first element, second element and third element, I can delete this one. Therefore, 4 is an element which is not third element to be inserted, friends, okay, because 4 is a second element to be inserted here. If you follow one particular order, it is first element, second element, okay. So answer this question is 4 is a correct answer, friends, okay. It is also very beautiful question. Yeah, it is straightforward question for counting number of nodes in the given singly linked list, friends, okay, in the singly linked list. Just observe how did I ask this question. Suppose if you consider linked list structure, so we are having fields like data field and the next field, data field and then next field, friends, okay. Suppose if you have data is equal to A, let us assume that first node address is 100, next node address is 200. So next is a pointer which contains next node address, let it be data is B, here it is pointing to null. Just imagine like this, okay. And there is a head node which is always pointing to starting node address. Is it clear, friends, okay? Now just look at here. They are asking about finding total number of nodes in the linked list. So they provide 2 statements, expression 1, E1, and second one is expression 2. See, when you say there is only one node existing, we can say one node existing if head cap next is equal to null. Correct, friends, okay? It means that suppose if this value is equal to null, next is pointing null, then head cap next is equal to null, obviously we can say one node existing. Therefore, E1 must be equals to head arrow next is equals to null. If this condition satisfies, we can say only one node is there, where that node is pointing by head. If there are more than one node is there, then obviously E2 is nothing but. If this condition fail, okay, if this condition fail, of course it is assignment operator like this, okay. Head is equal, let me write properly. Suppose if this condition fail means at least one node is available, right? So therefore I can take one node. Afterwards you can recursively call this function, okay. So we can call get size is a recursive function, and we can take simply head cap or head arrow next. So this is the ET expression such that we can iterate this loop until we reach the value is equal to next point is pointed to null. So therefore that is E1, it is E2, friends, okay. This question asks linked list. Yeah, this question based on spanning trees. Actually, in fact, this question directly I have taken from the PYQ questions only. If you think logically, this question already covered in the class, friends, okay. See, there is a graph, undated graph with distinct edge weights. This is the most important keyword. They clearly mention the distinct edge weights. Distinct edge weights. And which of the following statement is true about the minimum cost spanning tree? about the minimum cost spanning tree. Just look at first one. Same question we evaluated in the PYQ also. For all cycles C in the graph, the minimum weight edge of each cycle must be present in the MST. Means as many cycles are in the graph, okay, from every cycle minimum weight edge must be included in the MST. So we took same example by taking 4 vertices in the graph. You can take V1, V2, V3, V4. Just imagine this edge is 1, weight is 1, it is 2, and you can consider this weight is equal to 3, it is 4, it is 5. So in this graph there are 2 cycles are possible, friends, okay. Let me show those 2 cycles with a different color, you will get clear idea. So this is one cycle, right, friends, okay. So it is another cycle. I can say this is C1 cycle, it is C2 cycle, friends, okay, C2 cycle. If you apply Prim's algorithm to find minimum cost spanning tree, the spanning tree must be looking like this. It is first taking 1, because spanning tree, minimum cost spanning tree always including edge weight with the minimum weight, right. Then include 2. After including 2, I cannot include 3 because it is forming cycle. It is forming cycle. So therefore, after 3, next I can include 4. That's all. Therefore, the minimum cost spanning tree only indicate dotted line. It is looking like this. This is a minimum cost spanning tree. We have 1 and then 2 and then 4. This is the weight of minimum cost spanning tree, friends, okay. It is just weight of minimum cost spanning tree. But what did they mention in the question? For all cycles C, in the graph, the minimum weight edge of each cycle must be present in the MST. If you observe, friends, for the cycle C1, who is the minimum weight? 1. 1 already presented in the MST. But for cycle C2, who is the minimum edge? Means 3. For cycle C2, 3 is the minimum weight edge. But 3 is not presented here, right? Therefore, this statement is false. Okay? This statement is false. They are asking about true statement. It is a false statement. Next, for any cycle in C, the maximum weight of edge in the cycle must be excluded from the MST. Of course, friends, okay. When you take any cycle, maximum weight edge compulsory excluded. Otherwise, it is increasing the weight of the minimum cost spanning tree. Okay. So therefore, this statement is true. That statement is true. Next, for every vertex V, the largest weight edge incident on vertex V, the largest weight edge incident on vertex V not included in the MST. No, it is not correct, friends. Okay. For example, you just consider simple example. Let us consider 1, 2, 3. Here we are taking 4. So let us consider 3 vertices, 4 vertices V1, V2, V3, and then V4. If I consider minimum cost spanning tree for this graph, the minimum cost spanning tree of this graph is simply, first we can include 1, afterwards we can include 2, but we cannot include 3 because it is forming cycle, then we can include 4. Right, friends, okay? So therefore, if you consider this vertex V1, for this vertex V1, this is the edge which is having maximum weight, right? Okay. Now look at this one. For every vertex V, they are talking about for every vertex. For every vertex V, the largest weight edge incident on V is not included in MST. No, it is included. It is included. So that's why it is false option. It is false option. Next, for every vertex V, the smallest weight edge incident on V is not included in MST. Actually, it is, I think, the main mistake here. I remember this question. For every vertex V, the smallest weight edge incident on V is included in the MST. That is the correct statement they provided. So if they provided a statement like that, obviously it is true, friends, okay? Because according to Prim's algorithm, you always select an edge which is crossing the cut with the minimum weight. That is possible only if you select the smallest weight edge. So smallest weight edge crossing the cut with the minimum weight. So therefore, it is D is true and B is true for this question, friends, okay? Yeah, they provided pre-order traversal of binary search tree is given like that, and determine the position of the node 60. Determine the position of node 60 in post-order traversal they are asking. Starting from index is equals to 1. See, once they provide pre-order traversal, you can easily construct binary tree, right? You can easily construct binary search tree. So since they provided pre-order traversal, just go through in-order traversal. In-order traversal always in ascending order only, right? So therefore, if I write ascending order for this tree, so first who is coming? 13. Please check it once. Next one is 25. Next one is 40. Right, friends, okay? So 13, 25, 40 completed. After 40, next one is 50. Next, we are getting 60, 70, and then 75, 80. So just we are in the increasing order, friends. Okay. This is called in-order traversal. This is called in-order traversal. It is called pre-order traversal. Once you have in-order and pre-order, just try to start constructing binary search tree. So how do you construct? First key of pre-order always root node. So simply construct by taking first key of pre-order, that equal root node, that equal 50. Then identify that 50 in order, right, friends? Okay. These are left subtree of 50. These are right subtree of 50, friends. Okay. For left subtree of 50, 13, 12, 25, 40. Who is the first node? 13. So therefore, next we can take 13. Right, friends? Okay. Identify 13 here. For 13, we are having right side 40, 25, and 40. So in 25 and 40, automatically they are coming in the right subtree only. Right, friends? Okay. So 25 here, 25. So we can consider root node is 25. After 25 right side we are having 40. So this is a place we can insert 40. So left subtree is over. Okay. Similarly, if you consider right subtree 60, 70, 75, 80, the first node is 60. So therefore, it is acting as a parent for the subtree 60. Now identify 60 here. Again, we are having 70, 75, 80 on the right subtree. So therefore, here there is no space. Let me take it as 70. Consider it is 70. Right, friends? Consider it is 70. So after writing 70, so identify 70 here. So right subtree we are having 75 and 80. Okay. So 75 and 80, one more element is also there, right? That equals 77. You can consider 77 also. Okay. So therefore, after taking 70, we are having, there is small correction, please excuse me. After picking up the first key of the pre-order sequence, that equal 50, identify 50 here. Left subtree we are having 13, 25, 40. So in 13, 25, 40, 13 is the root node. So therefore, I have taken 30 is root node. And right side we are having 25 and 40. In 25 and 40, so I am taking 25. And again 25 right side is 40. So therefore, I am taking 40. So left subtree is over, friends. Okay. Now look at right subtree part. After root node, right subtree part is starting from here. 60, 70, 75, 77 and 80. So just focus on 60, 70, 75, 77 and 80. Among all these nodes, which element appear first? Obviously that element is 75, friends. Okay. Here we are having 75. So therefore, you can pick up that node 75 and create a node of it. Identify 75 in order traversal. Yes, we are identifying 75 in order traversal. Then 60 and 70 left subtree. So left subtree 60 and 70, and right subtree we are having 77 and 80. In 60 and 70, who is coming first? 60. So we can take 60 here, and right subtree we are having 70. And 77 and 80, who is coming first? 80. So I can take 80, and 77 must be left subtree. That's all. So this is a binary tree. What did the last question? Determine the position of the node 60 in the post-order traversal. Now we can apply post-order traversal for this, friends. Okay. Just apply post-order traversal and find the answer for this question. Okay. I think post-order traversal for this one is 40, 25, and then 13. Afterwards, we can take 70, 60. Then we can take it is 77 and 80, and then 75. Finally, we are having 50. Finally, we are having 50. So therefore, 1, 2, 3, 4, 5. So it is a fifth position if the question is correct. Okay. If the question is correct, definitely it must be fifth position. This is the way we need to identify the position. Very simple. After constructing, you can apply post-order traversal. Please check all the elements are correct or not, friends. Okay. The question is correct. That is the correct position for this one. Yeah, this question already discussed here. Okay. So these are different types of questions asked in algorithm, data structures, and programming. And now my colleague, Mr. Vamshi sir, is going to discuss discrete mathematics questions. Okay. Thank you for giving the opportunity.
Uh, Hi students, very good evening. This is Vamshi Krishna. Now I am going to discuss questions from discrete mathematical structures. My dear students, totally we got 4 questions in the morning session from our discrete mathematical structures, and that questions are 2 are MSQ questions and 1 is NEAT type questions. So one question is NEAT and general MCQ question is 1. So we got the 2 questions from graph, and 1 question is related to combinatorics, and 1 question is based on recurrence relations, right? So the recurrence relation part question already discussed by our algorithms faculty, so I don't discuss this MCQ question again. So I will go for these 3 questions. Let G be the undirected graph, which is a path on 8 vertices. Yeah, my dear, it's a path of 8 vertices in the sense how many matchings are possible. So this is a question which can lead you something like a confusion. What usually you can think when you think about number of perfect matchings, the number of perfect matchings possible on n vertices, k to n, it must be even number, right? K to n, it comes to 2n factorial by 2n factorial by 2 power n into n factorial. This is the usual perception of the average student. My dear, here the scenario is different. They are asking about matchings. Matching is nothing but a spanning subgraph. In that subgraph, degree of every vertex is going to be at most 1. So, but and another more condition is they given a path graph. So in our data structures or in our algorithms or in our discrete, we can call it as a path or walk or line graph, whatever the terminology you can use. So if I take only one vertex, one graph I can prepare. If I have 2 vertices like this, yeah, this is the original path graph, let me say, and here I can prepare 2 graphs like this. I hope you got this, these 2 things are 2 graphs. And if I have 3 vertices in this way, just like 1, 2, 3, my dear, the original graph is, it's a path graph, right? It's a path graph like this. From this, I am preparing matching. This is one matching, and this is another matching, right? And this is another matching. So if you ask me to give some clarity, I can give like this, just like G1, G2, G3, G4. So in this scenario, you are going to get the graphs. So the first graph consists something like one vertex, and this G4 I cannot take it because degree of this vertex becomes 2. So I can't take this G4, and I can say G1, G2, G3, these 3 are the graphs. And in similar way, if I take the 4th graph, 1, 2, 3, 4 like this, from this how many path graphs you can prepare? So you can prepare matchings, on this a path graph of length 3 units. So you can prepare some 5 graphs like this. I hope you are getting the point slowly. So when if it is A1, the A1 value is 1. If the number of vertices is 2 here, you are getting 2 types of graphs like this. And if the number of vertices is 3, then 1 plus 2 you are getting 3 like this. And A4, 2 plus 3 is equals to 5. My dear, this is actual logic behind this. Then you can understand the Fibonacci series like an is equals to an minus 1 plus an minus 2. This is the actual recurrence relation what we can frame from it, right? Yeah, we can frame the recurrence relation in this way. Now, when you are taking in this way, the requirement is A8. If we proceed to the Fibonacci, so A8 is comes to some value like 34. 34 will be the correct answer. So I don't want to discuss the formula. Even if they ask A100 also, You can break the logic by taking an is equals to 1 by root 5 of 1 plus root by 2, 1 plus root 2 by 2 whole power n, plus or minus 1 minus root 2, some formula we have. We derived that formula in recurrence relations by using the characteristic root method. We did not simply break the Fibonacci series, we derived that thing by using recurrence relation logic characteristic root method also. But in GATE approach, we solved in a different way by options verification we did. Coming to the conclusion, answer to this question is 34, right? And coming to this area, my dear, this is another MSQ question. The question consists, two colorable graph is there, and which of the following statements is going to be true. So what they are conveying here, this is the graph which is two colorable, in the sense the chromatic number of the given graph is true. The minimum number of colors required to color the graph by following the logic like proper coloring, vertex coloring by using Wells-Powell's algorithm, right? I am just stressing the words. I hope you are remembering all our classroom discussion. So by using Wells-Powell's algorithm, if chromatic number is 2, then what can be happens? So different options are available here. So if you see option C, the two coloring graph can have a cycle of even number of edges. Even number of edges are possible and odd number of edges are possible. When you see some solutions, you may have some controversy. You may thought like there is a graph, it can be some line graph, and for this line graph the chromatic number is 2, but there is no even length cycle. You may thought like this, your thought process can be, but here actual thing is they are thinking about a cycle. When they are taking about cycle, my dear, when the chromatic number is 2, so odd length cycle is not possible. Red, green, blue, you required 3 colors here. So if you take even length cycle, just like a cycle on 4 vertices, so C4 graph like this. So in this scenario, you can get red color here, blue here, red here, and blue here. You can use 4 colors also, that can be proper coloring, but I am focusing on chromatic number. The chromatic number comes to 2 colors actually. So when there are 2 colors, we can confirm the option like the graph can contains even number of edges, right? And when you are taking the optimal solution, so when you are trying to find any particular node in total traversing process, what is most important when you are thinking about time complexity or space complexity, how many nodes you are visiting, that is very, very important. But every graph is not going to be tree. You should understand in our discrete mathematics, the graph can be any form. Don't think like tree, right? But if you are going for optimal solution, the number of edges and the number of vertices matters a lot. How many nodes you are taking and how many edges you are allocating in the graph. So that is the reason I can confirm that option B can also be the correct answer. The optimal solution for 2 coloring graph is, it's a big O of order of cardinality of E plus cardinality of E, and this is different option, card E into log V we cannot say, and odd length also we cannot say. I hope this solution is clear to you. Fine. Yeah. My dear, coming to this area, you see this peculiar question. There is a 4 by 4 matrix. In that 4 by 4 matrix, the possible entries are 0, 1. So I think almost nowhere till now you can find the solution to this question, but let me do, I can do this for you. My dear, it's a 4 by 4 matrix here. In this 4 by 4 matrix, the possible entries comes to 16 here. So in 16, you can prepare the possible matrices 2 power 16. Every element is having 2 possibilities, either 0 or 1, right? Let's say if it is something like the matrix 1, 2, 3, 4, 1, 2, 3, 4. What I am doing here, all rows and columns have even number of ones. So if I take 1 here, So all 4 ones are not allowed. I can go with this type of example, right? So if I fix one entry here, the remaining possible entries are comes to n minus 1. If I remove one column and one row fixed like this, the remaining part maybe in determinant of linear algebra, when you are finding the determinant how you are going to eliminate the things, the remaining part comes to n minus 1. That n minus 1 consists n minus 1 whole square entries. In that n minus 1 whole square entries, every element is having two possibilities. Then the answer comes to 2 into 2 into 2 n minus 1 times like this. This is 2 power n minus 1 whole square. This is the actual logic behind this formula, and which is equals to 2 power. Here let me take n value given in the problem is 4. So 4 minus 1 whole square, 3 square, that's 9. I can get answer like 512. Yeah, my dear, this is the question we got from combinatorics, and this is the question we got from graph, and this is the another question we got from same graph only. So in the morning session, what we observed is he touched only last 2 units, combinatorics and graph. Until now, whatever the information I have, so as usual what we expected from the logic part and the set theory part, definitely afternoon session people will get the questions. The same thing happened. I already got some 2-3 questions, and I can discuss that things in the next session. My dear, in this complete graph, you should understand it's like different scenarios. So if it is only for matchings without thinking about anything, then by using the programming concept telephonic number, you can break the recurrence relation by using T of n is equals to T of n minus 1 into plus n minus 1 into T of n minus 2. That means all possibilities you are getting. If there is no condition, there are 8 vertices with you. In that case, if you want to find the solution, let me initiate the things. Just like T of 1, T of 0 value is 1 and T of 1 value is also 1. Yeah, in that case, that T of 8 comes to, as I remember, 762 you can get. All 3 cases I discussed here, but actually the thing is, it's a path graph. That is the reason answer can be Fibonacci 34. My dear, one more 4th question is given. The T of n value, T1 of n is equals to T1 of n by 2, n minus 1 plus T2 of n minus 2. Some question given with 2 relations. It's already discussed in algorithm. It is also the common concept of recurrence relation. In some places what you are watching like theta of n square, that is not correct answer. I hope you can find the right answer, and fine. Coming to next part, next my colleague will take over the session, and you people stay tuned.
Okay, good evening students. I am Dr. Manikumar. We will discuss mathematics question. As per student memory, we have received 4 questions in mathematics. You see, this is a first question in calculus. F of x is equal to mod x by 2 minus x into x minus of mod x by 2. 4 options given. See, generally mod x we have to simplify here. Simplification of mod x. What it is? Mod x is equal to x if x is greater than or equal to 0 minus x if x less than 0. So, you divide that function in 2 forms. If you divide like this by taking mod x is equal to after at 0 and after 0 mod x you write as x. Before 0 mod x you write as minus x. So, totally the function will be after simplification the function will be divided like this, that is minus x square by 2 4 direct simplified step I am writing x greater than or equal to 0 minus 9x square by 4 x less than 0 will get. Okay, very clear. Now, if you take the graph of this function, the graph, rough graph I am drawing, okay, graph will be roughly like this. Okay, so very clear. Clearly, the function has a local maxima from this graph, the function has a local maxima. Local minima means the graph is going downwards, means not possible to guess, but local maxima, f has a local maxima is clear. Okay, f dash is continuous at x is equal to 0. This is f of x. What is f dash of x? F dash of x is nothing but minus 2x by 4, x greater than or equal to 0, minus 18x by 4, x less than 0. Clearly at x is equal to 0, left limit and right limit both are becoming 0. So, left limit and right limit both are equal, that is equal to f of 0 also. Yes, it is continuous function at x is equal to 0. Next, f dash is not differentiable. F dash is not differentiable means f double dash does not exist. That you have to verify. What is f double dash of x? Minus 2 by 4 means minus 1 by 2, x greater than or equal to 0. So, minus 18 by 4 means minus 9 by 2, x less than 0, very clear. Left derivative and right derivative both are not equal means function is not derivable at x is equal to 0 is right. So, options B, C, D are correct. This is MSQ question. Okay. Now, coming to the next question. For n greater than 1, the maximum multiplicity of any eigenvalue of n by n matrix with real entries. Multiplicity means repetition, very clear. So, n by n matrix, suppose if all eigenvalues are repeated, all eigenvalues, suppose n by n matrix means n eigenvalues are there, you just assume. If all are repeated, in that case also what is the maximum multiplicity? That will be n. If no one is repeated, that is 1. If all are repeated, so that is n. So, maximum multiplicity of n by n matrix is nothing but n only. Actually here, this is a MCQ question, options given. I think options also given, but answer is n. One of the option will coincide as n. Okay. Coming to this question, actually here some small typo error. That is, actually here it is C2, this is not C square, better I will use white mark. C2 log, okay, C2 log 1 by x to the base e. So, for x greater than 0, function is given like this, C1 minus C, what it is clearly I will write here. F of x is nothing but C1 e raised to x minus C2 log 1 by x to the base e, x greater than 0. 3 otherwise means greater than or equal to 0, sir, less than or equal to 0 it means. Function is continuous at x is equal to 0. Function is continuous at x is equal to 0 means limit must exist, means left limit should be equal to right limit at x is equal to 0. At x is equal to 0, what is left limit? Left limit value is nothing but 3. L of f of 0, just I am using like this with a notation. Left limit value is 3. What is right limit at 0? Right limit at 0 is nothing but C1 minus C2 into, we are getting 1 by x tends to 0, 1 by 0 is infinity or not. But already function is continuous given. Function is continuous given means it should not be infinity. Only possibility is C2 should be 0. Function is already continuous given. Function is already continuous means it should not be infinity. So, it should not be infinity means when it is possible, it should get a finite value. When it is possible to get a finite value, C2 should be 0. So, So C1, since f is continuous, left limit is equal to right limit. L of f of 0 is equal to R of f of 0. So 3 is equal to C1. Already C2 is equal to 0, means C1 is 3. C2 0. Already C2 0 according to our assumption. Therefore, what is C1 plus C2 finally? Answer is 3. Is it? Now coming to the next question. If for n greater than 1, if 0, 1 and so on belongs to R power n is belongs to null space of A. Then very clear. See, this is one non-zero vector. Non-zero vector belongs to the null space of A means that implies from the given data. Null space of A means what is the meaning? Ax is equal to 0 has non-trivial solution. Means it has non-zero solution. Non-trivial solution means what is the meaning? System has infinite number of solutions and A is a square matrix. If for a square matrix system has infinite number of solutions means determinant of A should be 0. Option A correct. Is it? These are the 4 questions in mathematics as per students' memory. Next, our aptitude faculty will discuss aptitude questions.
Last but not least, from the aptitude, we are getting 2 questions only from the memory based. I know this question everybody, answer is 7 by 18. And second one, number of the badminton questions, total 64 members, how many matches done? So 64 minus 1, 63 matches done. So these 2 questions from the aptitude. All the best. I hope everybody did good. Thank you.